She's an O'Reilly author of Learning Responsive Web Design, and she's here to give us a talk about responsive color on the web, I presume. Join me in welcoming Clarissa.
Thank you. So if you ever watched old cartoons on TV, like Merry Melodies, Bugs Bunny, that sort of thing, you might have seen it says color by Technicolor a lot of times on the title screen. And you might wonder what that means. And what Technicolor is or was, it was a process for adding color to motion pictures. When they first had movies, of course, they were in black and white, and it took them a while to figure out how to put color onto the film. So they tried a bunch of different processes, and Technicolor was kind of the one that won out at first. And The Wizard of Oz was one of the first major movies that used Technicolor. And this is the first time they could really take advantage of color, and they really used it a lot in this movie. Like you can tell the green of the witch's face or the ruby red of Dorothy's slippers. And it's interesting because you can see from this, color has a power to transform an experience. The shoes were silver in the book, The Wizard of Oz, but when they made that movie, they decided to make them ruby red to make them stand out, to transform the experience into something even better, just because they could, because they had this awesome new process for adding color to movies. TV, too, started out in black and white, of course. And although color transmission became popular in the 1960s and 70s, it was quite a while before everybody really had color TVs at home. And that's why you saw signs like this a lot on motels, and still sometimes you see them, because you'd go on vacation. If you had a black and white TV at home, it was really exciting to go stay in a hotel and be able to have a color TV and see this awesome color on the screen. In my house, we didn't have color TV till I was 10 years old. So Big Bird was gray. The Smurfs were gray also. Everything was gray. But that was fine, because you still got the story. It didn't matter. The message and the story was still there, no matter whether you saw the colors or not. But once we did have color TV, it was pretty cool. And TV now, of course, it's just millions of colors, and it's beautiful and high resolution, and it looks like you're just looking at the real thing when you look at the screen. Computers started out not in black and white, but monocolor, often with green text on a black screen like this. When we first had the web, monitors couldn't display all the colors that they could display now. They could only display, a lot of them, 256 colors. And what we did back then is we had a chart like this. There were only 256 colors you could use in CSS and be sure that that color would be displayed correctly on the monitor. So you had to pick one of these 256 web-safe colors in order to get that assurance, because if you picked any other color in CSS, a different color number, it could really turn out to be anything, depending on what the monitor decided to make it into. You had to use one of these safe colors to make sure your design looked the way you wanted to. Now again, of course, on computers, we have millions of colors. But websites are different than movies and TV. With movies and TV, we know the story is the most important thing, right? It doesn't really matter if you can see the color that much, because you're there for the story. Websites are usually static, and we think of them more like a printed photo, because, photos, you print them out, you have control over the paper and the colors and the ink and everything. You just make it look the same every time. And we think that we can do that with websites, because that's how we, kind of associate them. But the truth is, we can't, because there's a screen in between. We don't have control over the whole process like we do with printing. And I'm going to talk more about that in a minute, but first I'm going to go into a little bit about how color works in CSS, how the color gets on the screen. There's three qualities that make color what it is: hue, value, and saturation. The first of these is hue, and this is what we think of when we think of color: red or green or purple. But that's only part of the color. The second part is value, which is the lightness or darkness of the hue. How much white or black is added? Here we have in the middle a pure purple, and then lighter and darker values of it on either side. Value is actually the most important part of color, because it determines how we recognize things that we see. So if we take a picture like this, and we remove the hue and just leave the value, of course we just get a black and white picture. We can still recognize everything. The people look like people and the trees look like trees, but you can't do it the other way around. You can't have hue, or the color, the red and the green and blue, and have everything as the exact same value, because your eyes would not actually be able to recognize anything. It would just be a jumble of color. Saturation is the third quality, and this is the intensity of a hue, or how much gray is added to it. So here at the top, we have a fully saturated red down to a fully unsaturated red at the bottom. So this is adding gray, or basically adding black and white at the same time to get a more dull or muted color. So this is what something looks like in full color. And then if we desaturate it, it's going to look more gray like this. If we made it darker, change the value instead of the saturation, we're adding more black to it, or add more white to it to have a different value this way. In color notation in CSS, this is pretty much the first thing we learn in CSS, how to write out the colors. But it's important to know where these colors come from. The colors on the screen are dependent on what the light is that is received by your eye. And the screen gives you a combination of red, green, and blue that mix together to make all the different possible colors you can see. So a pixel on a screen, you know, is like the smallest bit of color on the screen. But a pixel is actually made up of 3 separate subpixels, which are red, green, and blue. And each of the 3 subpixels are lit to different intensity to determine what the color of that pixel is. So there's 256 values for each of the possible, for each of the 3 subpixels. And multiplying that out, you get more than 16 million possible colors that you can put in any individual pixel. And this is far more colors than the eye can differentiate between. So there's two main ways to write color notation in CSS, RGB and HSL. And RGB is older and more common, and hex is an example of RGB. That's usually what we learn first. In RGB, you're going to say what the value of each of the 3 subpixels should be. There's 256 possible values for each one. So you might use integers, so you can have an integer between 0 and 255 for each of the 3 numbers, like on the top line. So here we have RGB and then 3 numbers in parentheses. The first is the amount of red in the color, the second the amount of green in the color, and the third is the amount of blue in the color. It's pretty straightforward. The second line is the same thing, except we're using percents instead of integers. So we're going from 0% to 100%. An interesting thing to note, or just to remember, is you can't mix integers and percents in the same declaration. You can only use one or the other. Hex works the same way, except it uses base 16 numbers instead of base 10 numbers. So instead of 10 possible digits, you have 16 possible digits, with the last 6 being the letters A through F. So for each of the 3 colors, red, green, or blue, we have a 2-digit number in hex from 00 to FF, which, again, this is 256 possible numbers for the red, green, and blue. And it's just a pound sign with those 6 digits after it, or sometimes can be shortened to 3 digits. The problem with using RGB for color is it's not easy to look at a number and know what color it turns into. For example, let's say I wanted to have yellow. How much red, green, and blue do I need to mix to make yellow? Some people probably know the answer to that, but I'm pretty sure most of you don't. I don't know off the top of my head, and I'd have to look it up. So then comes around HSL notation, which makes this a lot easier. HSL is newer to CSS. The letters stand for hue, saturation, and lightness. Remember, we were just talking about these qualities a minute ago. Unfortunately, HSL is not available in IE8 or older, so we have to use a fallback color if we're supporting those browsers. You can use SAS to automatically make your fallback color, so that works out okay. The 3 numbers here, it looks similar to doing RGB, but the 3 numbers mean something different. The first is hue. Here we have 120, which is green. And hue, remember, is our actual color, like green or blue or red. And to get the number here, all the colors are in a circle with 360 degrees going all the way around, with red being 0, green is 120, blue is 240, etc. So you just have to be familiar with this color wheel to pick the number you want as your starting hue to get the color you're going to get on the screen. The second number of HSL is the S, which stands for saturation. So you're going to say how much gray you want in this color. Here we have 100%, so there's no gray. The third number, L, is lightness. 50% is normal. If you have a higher number, you're going to have more lightness, or 100% would be white, so a fully light color, or 0% would be black. So you can have any percent for the last number. And notice here the first number is the integer. First number is an integer, and the other 2 number are percent. So it's important to do those the right way. So the numbers we have right here give us just a plain bright green that's fully saturated and is at normal lightness. If I change the second number from 100% to 50%, it's less saturated. I'm changing the saturation. If I change the third number to 20%, it's a darker color. If I change the third number to 80%, it's a lighter color. So it's pretty straightforward. It's a lot more intuitive than RGB. So if you're designing in the browser and you just want to pick colors out of your head and make them into numbers, HSL is really the way to go, because as long as you know what color you're starting with on the color wheel, you can just adjust the other numbers to get to the actual color you want. Unfortunately, it's hard to go from an application like Photoshop to get HSL numbers. So usually if you're starting with a design in Photoshop, it is easier to use some version of RGB. Opacity is an interesting part of color notation that's newer to CSS also. And opacity is how transparent something is. RGBA notation, it works exactly the same as RGB, except you're adding a fourth channel at the end, A, which stands for alpha, a measure of opacity. So this is what your notation would look like. You just have the fourth number there, which is going to be an integer ranging from 0 to 1, or decimal ranging from 0 to 1, with 0 being transparent and 1 being opaque. Colors are fully opaque by default if you don't specify. And you can only do this with RGB integers or percentages, not with hex numbers. So this is what different opacity would look like. These are 5 blue boxes. The top one has an opacity of 1, so it's fully opaque. You can't see the text behind it. The bottom one has an opacity of 0, so it's fully invisible, and you just see the text, you don't see the box. And then different levels of opacity between it. How CSS determines what this looks like, when the blue box and the red text overlap, for each pixel, it figures out the value of the blue and the value of the background and the value of the foreground and combines them to make a new color. So what you actually see is kind of a purplish color where the blue and red overlap. HSLA notation works the same way, just like HSL with the 3 numbers, and then you add the 4th number on the end for opacity. There's also an opacity property in CSS, but it works differently. It applies to the whole element. So here, when I have a div and I apply opacity to it, that makes everything in the div opaque. The background is opaque or transparent. The background is transparent, the text is going to be transparent, and the border is going to be transparent. So if you want to make just part of something transparent, you can use the color notation. Let's say I just wanted to have the background transparent. I don't want to use the opacity property. I want to use RGBA or HSLA, so I can just apply that to the background and make only that transparent. So that's how color notation works in CSS. But now we're going to get to the part that's important to users, which is how the color looks on the screen. So when we pick out colors that we want to have on our website, not everybody sees the same color, and that's something really important to think about. The most obvious thing is color blindness. 1 in 20 people are colorblind. It's more common in men. Color blindness is really more accurately called a color deficiency, because it's not that people can't see color at all, it's that they don't see colors the same way as everybody else sees colors. There are different types and severity levels. Here's an example of 3 different types of color blindness. The top left rainbow right there is what a normal person with normal color vision would see. And the other 3 rectangles are the same rainbow as somebody with color blindness would see them. So you can see that the colors look very different. The most common type of color blindness is green and red color blindness, which makes reds look like greens. So this is what somebody with normal color vision would see if they went to a fruit market. A lot of different colors here. If you had red-green color blindness, you would see this. And I look at this, I'm like, how do you even pick out fruit because it's all the same color? It's like crazy. And this was really something, when I saw this, I'm like, oh, wow, that's amazing. Because we kind of think of color blindness in our heads, we know that's a thing, but we don't really understand how it changes what people see. And it's not just that they don't see colors, it's that they look at things and can't tell things apart as well because they're the same color instead of different colors. And obviously people who are colorblind adjust to that in some way, but when they're looking at a website, they might not be able to tell apart colors that we can tell apart. There's also, of course, some grayscale browsers like Kindle, some game consoles. An important thing to think of when you're putting a website together is not relying on color to convey meaning to people because they might not all see the color. A stop sign isn't a good example of this. Stop signs are always red, it makes it really clear. You're driving down the street, you see red, it's a stop sign. But it also has 8 sides, so it's also clearly recognizable to somebody who can't see the color red. So although the red does make it stand out, which is a really useful thing, there's also a backup for the other people that can't see the red. You also want to think about where your color is your content on a website. For example, this is a site where they sell shirts. And you can get this shirt in many different colors. If you hover over one of the colored boxes on the bottom, it shows you the shirt in that color and tells you what color it is. So let's say I'm a colorblind person coming to this site. I know I want to buy a light blue shirt because, people have told me I look good in light blue, even though I can't really tell the difference. So I look at this, I look at the colors, and it tells me this color is Persian jewel. So how does that help me if I want to buy a light blue shirt? It's actually pretty horrible. And this is something really super basic. I mean, there's obviously clothing designers out here that are like, wow, Persian jewel, this will make our shirt sound really exciting. But in reality, this makes it harder for people to buy your product, and they're going to go away and go to another store. So it's just something to think about. So since you don't have color blindness, you need a way to make sure that your website's still accessible to people who can't see the colors. And one thing you can do that's really easy, if you have a Mac, if you go to accessibility settings, there's a box you can check to change your monitor to grayscale. So if you just do that, you can go through your website, check everything, see how it works, see if any issues crop up. There's websites and tools where you can take your website and see how it looks with various color blindness options, but really the grayscale thing ends up being easier and faster just to give it a quick check. So besides color blindness, do we all see the same thing? No, actually not. There's perception of color. Now, we've all heard this, that women can see like 20 different colors of beige and men can only see beige, right? I mean, that's kind of sexist, but we've all heard that. But the thing is, it's a little bit based in fact, because they've actually done scientific studies and found that men are less adept at distinguishing shades in the middle of the spectrum, like blue, green, and yellow. So if they're shades that are really close together, a woman might be able to tell them apart and a man can't, just because their eyes develop differently. And this was like really interesting to me, something I never thought of. And men actually see some colors differently, like yellows look more green and reds look more orange to them. So if you're sitting next to somebody, you're a woman and sitting next to a man, what you see on the screen here might look slightly different to both of you. Just something to think about. Our language also affects our perception of color, oddly enough. So if we grew up in a culture like most of us did, where we have a box of 64 colors of crayons, we're used to applying different labels to colors, like red can be red or rust or brick. But not everybody grows up with that same kind of experience. For example, they did a study in one African language. Red and orange use the same word. They're not separate colors. There's just one color that covers both red and orange. But in the same language, there's several different words for shades of green. And it's just because of the way that they interact with their environment. For example, they might need to tell apart many different plants that are different shades of green, but there's not a lot of red and orange things around them, so different words never evolved to fit those things. Then there's what you think you see. We've all seen this, right? The dress. And the dress is blue and black, but the photo, it's overexposed in poor light balance, so it looks like it's white and gold. So we can go in here and look at each individual pixel and see what color it is, but the fact is it doesn't matter because we look at it and we think we're seeing something different. So that's really something important to take into consideration on your website, that people might not see what you think you want them to see. Then there's screens, which is another problem. Do colors look the same on every screen? And the answer is no. And you can see this if you ever go to a store that sells TVs. You'll see a whole line of TVs from different manufacturers playing the same show, except what you see on the screen will look slightly different. The difference between models and manufacturers can be slightly different. An individual device can change color over the years as it gets older. The problem is RGB that we talked about isn't actually color. It's just more like a recipe that each device can interpret any way it wants. And of course, they all show something pretty similar, but this device and this device might not be interpreting that RGB recipe exactly the same. Here I have a photo from my MacBook and my iPhone sitting next to each other. They're both at full brightness, but they display something actually pretty different. The blue is a lot darker on the left. And I was actually surprised at how different they were. So if you're sitting in front of a computer and picking out your colors very carefully, you might not realize they're going to look different on every device. Light also matters. Ambient light level, the brightness of the screen. This all affects how the colors look. If you're sitting in an office with fluorescent light, that's different than sitting outside in natural light. If you're in a dark room, the screen on your phone might change brightness to adapt to the light level in the room, and that will change the colors. If you're outside in bright sunlight, everything on the screen will look washed out, and it might be hard to see if there's not enough contrast. So we can do something about this. Well, we actually can't do something about this yet, but in the future, we're going to be able to do something about this. In CSS4, there's going to be light-level media queries, which work with the ambient light sensors on mobile devices to see if the light level dim or bright, and then you can change your CSS accordingly. So for somebody out in bright light, you might want to add more contrast to make it easier to see the screen. So then what do you do now? I mean, it doesn't seem like there's a lot you can do without this media query that's going to be really awesome when it's available. But you need to remember, your job isn't to make the colors look the same on every device. It's to make the site look good and to have good usability on every device. So the place to start is with testing. And of course, we already know to test on a lot of different devices, but we also need to go out and test in different light conditions. And almost nobody does this. But we need to. We need to take our devices, take them outside, and see if everything still looks okay. Because you're going to find a lot of times, if there's not enough contrast on the site, it's not going to work well in bright sunlight. And you can't query light right now, but you can query different screen sizes. So small screens are a lot more likely to be outside. So you can do a media query and change the color slightly on a smaller screen to add more contrast to make it look a little bit better. What you really want to think about is in bright light, you want to have dark text on light background because you want to increase the brightness on the screen to make it stand out in the bright sunlight. And these are just a couple of examples of sites that changed what their navigation looked like a little bit for smaller screens. On the large screen, they have white text against a colored background, which would be really hard to see in bright sunlight. So they have a lot more contrast on the main parts of their site for the smaller screens. Another thing to think about is printers. This should be in your device lab because people still print things and you want to make sure everything looks good when it's printed. And everything might be in black and white sometimes, or it might be printed in color, but the background color is weird or something like that. But you really should be thinking about this. And you can easily do print style sheets. We've been able to do this for a very long time, even before responsive design. And you don't need to do this as you're putting a site together. It can be something you do at the end. Just get your site working, make sure everything's done, and you'll probably only need to change a few things for print to make it look okay. I went to a recipe site recently, and I wanted to print a recipe, and I pulled it up on Print Preview, and it was 28 pages, starting with 5 pages of just the navigation, which is really bad, And the site, it did have a little print icon, but not everybody sees that. They just hit Control Print because they're used to doing that like I did, and they get this, which is sad because it's so easy to go in there and fix this. So the other thing I'm going to talk about beyond how colors look on the screen really quickly is a few things you can do to make it easier to work with colors, such as using Sass. And one of the things is color variables. It's the most basic thing pretty much in Sass. And you're just using a variable, which always starts with a $sign. So you might call it $green and assign it a color. And that way you can always use that variable in your CSS instead of typing the same hex number over and over again. And that also makes it easier if you need to change a color later on. You can only change it in one place instead of having to do a search and replace to find all of them. You can name colors however you want based on the color or based on the usage. There's a lot of theories on the best way to do this, which I won't go into. There's Sass functions you can do to change color, such as lighten and darken to change the hue. So for example, lighten function, I just have lighten the color and the % I want to lighten it, and then I can change it to a new color. You can do the same thing with darken to get a new color, saturate and desaturate, grayscale, or inverse to get the inverse of a color. And there's a lot of other functions you can do in Sass to change the quality of colors. This is just the tip of the iceberg. Blend is another thing that you can do in CSS, not in Sass. It's pretty interesting. It's newer in CSS. Background blend mode is actually the name of the property. And what this does, it blends a background image with the color or image in front of it. So you start with an image. Here I have background images goat.ping. And then I have a background color. I've picked purple. And then you choose a background blend mode. And there's a lot of different options. I chose multiply here. So I'm starting with a picture that looks like this, pretty normal. And this is what I get with that code, because it's taking the background picture and multiplying it with the purple that I chose as the background color. So you get basically a picture that's very purple. There's a lot of other options you can use in blend mode. Here's just a few of them: screen, overlay, darken, lighten, color dodge. These might sound familiar because they're the same options you can use in applications like Photoshop to change the color of images. But this is nice because you can do the same thing in CSS without needing a second image. The good thing about this, though, it's not supported in all browsers yet. It's supported in Firefox, Chrome, Opera, and Android, partially supported in Safari and iOS, and not supported in IE or Opera Mini yet. But it's an example of progressive enhancement, where this is something cool you can do. You don't want to rely on it for the basic function of your site, but just as an added thing. Like if you wanted to have a hover over an image to change the color, but you could do that with this CSS property rather than having to replace it out with a different image. You can also do blend mode in Canvas and within SVGs. So going back to Dorothy's Ruby Slippers, I showed you at the end a few cool tricks with color, but the most important point I want you to get out of today is how we think about color. And color has the power to transform an experience, but it's not the experience. And we need to stop placing so much so much importance on exactly what colors we put on a website, because not everybody's going to see the same colors. We already know with responsive design, we need to change our layout and our navigation and different things to make a site work well on different screen sizes. But we're still set on these colors. We pick a color in Photoshop, and we want it to look exactly the same in every device and every context. But that's not ever going to happen. So we need to remember our job is to provide an optimal viewing experience across devices, not providing the same experience for everyone. So we need to get out of this mindset and find better ways to apply color so we can make our sites look good for everybody. Thank you.